Download this code and get free GPT-4o from codegive.com, link in the description below. Certainly. One common optimization technique in Python is memoization, which can significantly improve the performance of recursive functions by storing the results of expensive function calls and reusing them when the same inputs occur again. This is particularly useful in problems involving recursive computations, such as calculating Fibonacci numbers or performing dynamic programming tasks. What is memoization? Memoization is an optimization technique that involves storing the results of expensive function calls and returning the cached result when the same inputs occur again. This avoids redundant calculations and can reduce the time complexity of algorithms. When to use memoization? Memoization is particularly useful in situations where you have a function that performs repetitive calculations. The function can be expressed in terms of previously computed values. The input space is relatively small or can be managed with dictionaries or lists. Example, Fibonacci sequence. The Fibonacci sequence is a classic example where memoization can be applied. The naive recursive solution has an exponential time complexity \o, 2n, but with memoization, we can reduce it to linear time \o, n, Naive recursive implementation. Here's how the naive implementation looks. This implementation recalculates the Fibonacci values multiple times, leading to inefficiency. Optimized implementation with memoization. Now, let's implement the Fibonacci function using memoization. Explanation of the code. One function definition. The Fibonacci_memo function takes two parameters, n, the Fibonacci number to compute, and memo, a dictionary for storing computed Fibonacci numbers. To check memoization, the first if statement checks if n is already in the memo dictionary. If it is, the function returns the stored value. 3 base case, if n is less than or equal to 1, the function returns n, which is the base case of the Fibonacci sequence. For recursive calculation, if the value is not in the memoization dictionary, the function calculates it recursively and stores the result in memo n. 5 return the result. Finally, the function returns the computed value. Performance comparison. You can compare the performance of the naive recursive solution with the memoized version. You will notice that the memoized version is significantly faster, especially for larger values of n. Conclusion. Memoization is a powerful optimization technique that can drastically improve the performance of recursive functions in Python. By caching results of expensive function calls, you can reduce the time complexity from exponential to linear in many cases. This technique is commonly used in dynamic programming and can be applied to a variety of computational problems.